Hi Melinda. In this video, I'm going to explain about the software tool which has to be used by us in order to carry out all the experiments which comes under part B. Part B experiments, as I already mentioned in the previous class videos, are the experiments which has to be done by the software suite. And as I said, in this video, you will learn how to use that software tool in order to carry out the part B experiments. Clear? And the steps that I'm going to explain in this video will be common for almost all the experiments, and hence it is very important to go through this video first before watching the coming videos. Clear? Okay. And one more point that you need to keep in your mind is all the experiments which comes under part B will be stated like this. Write the Verilog or Verilog hardware description language code for full adder, or for 8:1 multiplexer, or for 3 to 8 decoder, etc. and so on. And you need to simulate the given circuit and you need to verify it's working. And in the manual you can find the port description. I mean, here this part will give details about which are input pins and which are output pins. Clear? And this is the main code that has to be typed, or that has to be remembered by you in order to carry out this experiment successfully. Similarly, if I go to the second experiment, you can find port description here. I mean, description about the input and output pins, and this is nothing but the code. Clear? Okay, this is how you can find the code and description of the ports for all the experiments which falls under part B. Clear? Okay. In few minutes I will tell you where actually you need to place this, how to place this, and how to simulate and how to verify the working. Clear? Okay. Now directly we shall go to the tool. This is the tool that we have to use in order to carry out part B experiments, and I have already shared the link to download this application in the WhatsApp group, and even I have shared the key which has to be used by you in order to activate this product in your local machine. Clear? So to launch this, and by default, remember, installation is not difficult, just click next. Okay, and by default, after successful installation, you can find the shortcut in the desktop. Okay, like this. ISE stands for Integrated Simulation Environment, or you can make it simple. This is an application, particularly design application, which allows us to design the logic circuits. Clear? Okay, just double click on this to launch that application. You will get an platform specific error window. No need to worry about this. Click OK. Okay, and wait for few seconds. Okay, this is the environment that that will be provided by the tool, and every time you will get the tip. If you don't want this tip, just uncheck this and click OK. Clear? Okay. See, remember, every experiment in part B has to be carried out by defining a new project. So to define a new project, click on File menu option, then choose New Project, and a window will appear. Okay, and give a name for the project. Okay, let us state our requirement is to simulate the working of 2 input bit AND gate. 2 input bit AND gate. So I will give the name of the project as AND gate. So you can give the name as you wish, but try to give the name for the project so that it will reflect its objective. Clear? AND gate. And don't worry about the default values. Okay, the tool chooses the default, let it choose the default values, no problem with that. Clear? Just specify the project name in this window. Okay, click next, and as I said, don't worry about the default values, let it take the default values specified by the tool itself. Click next, and this is important, every project will have one source file, so you have to define one source file for all the projects or for all the experiments. So click on this new source button in order to define a new source. Click on this, a window will appear which allows us to select the source type. Okay, remember, in all the experiments we will define the code, or we will write the code in a file of type VHDL module. So you need to choose this, and you need to give the name for the module. Okay, I am giving the name of the module as M. Okay, let it choose the default values. Clear? Click next, and this is very important. In this window you will define the variables, generally input and output variables. Okay, in order to simulate two input bit AND gate, we need two inputs. Okay, I will call inputs as X and Y, and I will use Z for output. Clear? Okay, there is no rule that you should use XYZ only. You can label it as an ABC or PQR as you wish. Clear? But the important thing here it is, see the direction. Can you see the direction selection box has three options. One is in, out, in and out. In means for input, out means for output, or in other words, in means for reading purpose, out means for writing purpose. In and out means for both reading and writing purpose, or input purpose and output purpose. Clear? Okay, in this experiment, I want X for input, Y for input, and Z for output. Clear? Okay, let me explain once again. Since our requirement is to simulate two input bit AND gate, and I have decided that X, Y as input, hence I have chosen the direction of X as in, direction of Y as in, direction of Z as out. Clear? Click next and you will get a summary. Okay, if you have done any mistake here, you can go back by clicking this button and do the changes and come back to this window again by clicking next button in the previous window. Clear? Click finish. Okay, then click next. You no need to define any sources, just one source is sufficient for one project. Okay, click finish. Okay, and since as I said this is an integrated development environment, means you will find the editor here, compiler here, or simulator here. Okay, every tool which is necessary for the developer will be available in a single package. That's why it is called as an integrated development environment. Clear? Okay, and this is the code. This is the code which will be by default will be created by the tool itself. Okay, you no need to worry about this. Okay, and your job is you have to write the VHDL code between this begin and end, and this begin is and end is similar to, I think you are familiar with the main function like this. Main function in C, it is similar to main function like this. Okay, this begin indicates beginning of the main, and this end indicates ending of the main. Clear? But here we will not use this braces, okay, or flower brackets, okay, in order to specify the beginning of the scope, ending of the scope. Instead we will use end keyword here, begin keyword here. Clear? Okay, and since our aim is to simulate two input bit AND gate, okay, and inputs are X and Y, and which operation that I need to perform here between X and Y, right? AND operation, right? Clear? And remember, for every gates in this package they have given a keyword. Like for AND gate they have given AND keyword, for OR gate they have given OR keyword, for NOT gate they have given NOT, and for XOR like this. Okay, for all the gates has been defined, or you can use as a keywords here. Okay, clear? Okay, and where I need to store this result, I need to store this result in Z, right? Okay, in C or in C++, you will use equal to as an assignment operator, right? But in VHDL, remember, the less than or equal to operator in C is an assignment operator in VHDL. Means this operator is an assignment operator in VHDL. Means you are performing AND operation between X and Y, and then storing the result in Z. This is how you need to interpret. Clear? And every statement like C or in C++ or in other languages should be terminated with semicolon. Clear? Okay, this is how you need to write the code, okay, between begin and end. Okay, then after this, like in C, after typing your program, what you people will do compilation, right? So here we will not call it an compilation, instead we will call it an synthesis. Can you see here, synthesis? Okay, and now you have to search for a compiler which will check for the syntax of your source code. Clear? Okay, to find that compiler, okay, or check syntax option. Can you see implement design here? Okay, click on plus icon so that it will show the internal components of implement design. And can you see synthesize XST here? Okay, click on plus again, and there you can find an option called check syntax. Okay, this is what we have to do after writing the code in the editor. Okay, you no need to touch this part, you no need to touch those part, just you need to specify your logic between begin and end. Clear? Okay, after doing this, then you have to search for check syntax, which will be there under implement design under synthesize. Then double click on this, and it will ask for whether your work has to be saved or not. Yes, let it save. Okay, and you will get acknowledgement here. Clear? Okay, and this is like a console window or error window. If you have an error or a warning, you can find it here itself. Clear? Okay, but in this case we have a result called success result from the compiler saying that process check syntax completed successfully. It means we have compiled this code successfully. Clear? After this, so if I take an example of C programming, after compiling the C code, what you people will do, you will do the execution, right? Here instead of execution we will call it an simulation. Clear? Now we are almost we have completed 50% of our work for simulation. Okay, can you see a sources for drop down box or selection box here? Okay, initially it will be there in synthesis. Okay, after synthesis, after compilation, you have to go for simulation. And remember, we will use since we are using behavioral model, we have to choose behavioral simulation. After this, go to or click on project, click new source, and usually we will verify or simulate or verify the working of the circuit using a waveform. Okay, specifically test bench waveform. So this is the file that is needed in order to verify our experiment. Clear? Okay, choose the waveform, specifically test bench waveform, and give the name as wave or as you wish waveform or just W. Clear? Try to give a meaningful name. It's a good practice always. Then click next. Usually it should be associated with our module called M. Then click finish. Okay, don't worry about this window for the time being. Anyhow, we shall see in the coming videos. Click finish. Okay, this is important. So you can find a waveform like this. Okay, can you see here 3 variables x, y, z? Okay, x and y we made as an input. Have you remembered? So input pins can be identified with a different color. Okay, output pin can be defined with a different color. Can you see here? And even the direction, you can see here, x direction is towards this side, y direction towards this side, whereas z direction towards this side. Clear? Either you can use direction information or color information to segregate the input and output pins. And remember, always this low represent 0 and high represent 1. Low represent 0, high represent 1. Okay, this is the first signal value, x value. Okay, and you can't able to change the first signal value. Okay, can you see here? Because the tool will treat that as a clock. I will later on tell you what is clock. Clear? Okay, then you have flexibility to change the second input. Okay, second input in our case is y. Okay, see, completely it is 0 initially. Now I want to change this signal from 0 to 1. Can you see a color column here? Just if you put the mouse pointer at the top of the color pillar, and if you click on that, then the signal will change from 0 to 1. Okay, again 0, again 1, again 0, again 1. Can you see here? See, like this, you randomly provide the inputs for the variables. Clear? And no need to do high and low for the output, because anyhow it is meaningless, right? Okay, clear? So this is how you need to provide the inputs. After providing the inputs, just click save. Okay, this is the waveform, right? This is the waveform that we created. Select this, single click, and you have to search for a simulator. Where you will find a simulator, where you can find a simulator? Can you see process or sources, any tab here? No, right? Can you see a small arrow here? Click on this. Now you can find a tab called process. So you have to search for process first, then click on process, then you can find a simulator. So go inside the simulator and you need to simulate behavioral model. Can you see here? Simulate behavioral model. Then double click on this. Now you are executing your work. Okay, and finally you have got the result here. And don't worry about these values, 0 nanoseconds or 240, 480. Don't worry about this. Okay, but have a look at x, y and z. X and y in this case are inputs, z is an output, right? Okay, don't worry about this. Later on I will tell you what actually this 111 indicates. Clear? Okay, now randomly place the mouse pointer anywhere. Okay, if I point it here, okay, what is the x value here? Okay, this is the x, I mean this row represents, this is the x signal. At this point, what is x value? 1, right? What is the y value at the same point? Okay, to look at y value, have a look at like this. This is the y signal. At this point it is also 1. So if x and y are 1 in the AND gate, z should be 1, right? Can you see? Z is also 1. Clear? If x is 0, in this point x is 0, y is 0, then z is also 0. Clear? Now interesting, look at here. What is the value of x at this point? Is 0, right? It is 0, right? And what is the value of y at this point? It is 1, right? 0 and 1, 0 and 1 in case of AND gate, z should be 0, right? Okay, later on I will tell you, you can put what I can say, a timeline like this. If you find difficulty in the previous mechanism to explain the result, you can put a pointer like this. Now you can see here. Now you can make use of this column. Okay, now this, at this point, I mean at this line, what is the x value? It is 1. What is the y value? It is 0. What is the z value? It is 0. This is what the meaning of this, right? Okay, now either you can use the previous way what I said. If you find difficulty in that way, you can go for this. Okay, like this. If you can vary this like this. Okay, at this point, what is the x value? I mean at this point, what is the x value? It is 1. What is the y value? It is 1. If both are 1, what should the AND gate output should be? It is 1, right? If I need this, I mean at this point. Okay, x is 1, y is 0. Okay, for 1 0, AND gate should produce as 0. Like this, you need to verify I mean for all possible combinations of inputs, whether the AND gate is working or not. If you are getting the result, then I can say you have successfully completed this experiment. Clear? So this completes the very basic experiment, like simulating 2 input bit AND gate using design software suite called Xilinx. Clear? Okay, if you have any doubt with respect to this, then you can send me a message or you can contact me in personal. So thank you one and all. So in the next video, I'm going to explain the first software experiment and how we can able to simulate and verify that in the same Xilinx package. So thank you one and all.